Hello and welcome to your homework, Mrs. Herrera. Today we're talking about sequences. This is from your homework on page 798, numbers 3 through 11 odd, 15, 16, 19, 20, 21, and 27 through 33 odd. We're going to start by taking a look at number 3. Number 3 says, write the first 6 terms of the sequence. Well, a sequence is just an ordered list of numbers. Okay, and we're given a rule for the sequence. So A sub n stands for the position of the sequence, and n would be the position number plus 2 is going to be our rule. So if we think about this, if we want to find the very first term in the sequence, we have to find the first position, which would be A sub 1. And when we do that, we plug in our position number, which is 1, and add that to 2 because that's our rule. And we get 3. So the first term in our sequence is 3. The second term in our sequence would be 2 plus 2, which is 4. The third term would be 3 plus 2, which is 5. Fourth term is 4 plus 2, which is 6. Fifth term, 5 plus 2, 7. And our sixth term, 6 plus 2, which is 8. So the first 6 terms in this sequence are 3, 4, 5, 6, 7, and 8. Okay, let's take a look at the next problem. I'm going to take a look at number 15. The instructions for 15 says, for the sequence, describe the pattern, write the next term, and write a rule for the nth term. So let's go ahead and do it in that order. Describe the pattern. So I'm going to look and see if I can see a pattern, and usually what I do first is I try to find the differences between the numbers. The difference between 1 and 6 is a positive 5. The difference between 6 and 11 is also a positive 5. And the difference between 11 and 16 is a positive 5. So I can already see what the pattern is. It's going up. We're adding 5 to the previous term every time. Therefore, my next term would be 21. Finally, I need to write a rule for the nth term. Well, when I have what's called a constant first difference, this is a first difference. If it's constant, meaning it's going up by the same amount every time, like plus 5, or going down, minus 2, whatever that may be. If I have a constant first difference, I have a linear rule. And remember, if you go back to linears, that means I have an exponent of 1 only for my variable. But the nice thing about linear rules is that I can take what that constant difference is and multiply it by my n. I know that's going to be a part of my rule. So I know it's going to be a sub n equals 5n, and then maybe I have to adjust that some more. But I know for sure I'm going to have 5n in there somewhere. So what I like to do then is I like to plug in my n. So if you think about your n's being 1, 2, 3, 4, and 5, I'm going to test it out by plugging in 1, making some adjustments, and then testing to see it works for 2. So if I plug in 1 for 5 here, I would get 5 times 1, which is 5, but I need my result to be 1. So I would have to subtract 4 from that. So let's just double check this. So if I have a sub 1, 5 times 1 minus 4, yep, that would give me 1. So let's test it out for 2 now. A sub 2, or my position 2, would be 5 times 2 minus 4. Well, 5 times 2 is 10, and 10 minus 4 is 6, and I want my second position to be 6, and it is. So I know then that this rule works. If you have any other questions, please see me and Mr. Daniels, and enjoy your homework.